Hello. Today we're going to talk about the average and instantaneous equations of motion. These are the equations that will describe to us how objects move. And we're going to begin with a curve. So, in algebra, you learned about the linear function. And you learned how to get the slope for a linear function, just doing rise over run. And you learned also that that slope is the same for the entire function. The entire function has one slope. It's a straight line. But for a curve, we see a curve has infinitely many slopes. Every point on a curve has a slope. So for instance, let's say I just pick a point and draw what that slope would be at that point. Or maybe another point and draw what the slope would be there. And you can already see on a curve, there's going to be many different slopes depending on where you choose your point. And let's focus on just this one here. Let's say we want to figure out what is that slope for this curve. Well, with algebra, we can choose a point to the left, a point to the right, and connect these with a straight line. And since these are points on a function, we can go back to using the slope formula, rise over run, and we can get what the slope of this line is. And this line is called the secant line. It is the average value for the slope. So if we choose 2 points on the function, then connecting them with a straight line will give us the average slope between those 2 points. But that's really not what we're interested in. We want to know, what is the slope exactly at this point? Now this red line is called the tangent line, and it gives us the instantaneous value, the value right at this point, not some average value, but exactly what it is at this point. And this is the one we want to try to figure out. And what we can do with algebra is these gray dots we can bring closer. And you can see the average value starts to approach what the tangent line looks like. If we bring the points closer and closer to our point of interest, the secant line actually starts to become the tangent line. But algebra couldn't figure out in the long run how to get a numeric answer. So the secant line requires 2 points to get a value. This point, this point. While the tangent line only requires 1 point to get this value. And this was a struggle back in the 1600s, trying to figure this out. Isaac Newton eventually came up with what the answer is for us today, and we call it the derivative. Now, we are not a calculus-based class. I'm just trying to give you some background here, so don't worry. There's no calculus for us. But calculus is how we can get the slope at this point by using only one input. Where we can still use algebra though, but algebra gives us the average values. And so we have a standard slope formula here, rise over run. And I am using delta y and delta x because that's what you're familiar with. But for our notation here, I'm going to switch this to go to delta x and delta t. For us, x in physics commonly means our displacement, our position of our object, and t means time. So if our rise is position and our run is time, position over time is that when what we define as velocity. So we get the average velocity from algebra, and calculus gives us the instantaneous velocity with the derivative. So the two big equations to start with, that'll be in homework, is the average velocity, so an algebra from algebra there. And we can also make the same argument for the average acceleration. So from algebra, we have these average values. And this is what we will use in homework, the average value for velocity, and 1 or 2 have the average value for acceleration. And then calculus gives us these derivatives. And again, just trying to show some background here. But what we can do with calculus is we start with a constant acceleration. So acceleration is what changes your velocity. When you put your foot on your accelerator pedal in your car, that's giving your car an acceleration. It's changing the velocity. And where we start with in physics here is to just assume acceleration is constant. And that's what we're going to do. And this is going to be true for probably everything we do through the semester, that we will have a constant acceleration, an acceleration that's not changing. And if we start with that, calculus can actually generate some equations for us. Now, I'm not going to go into how that is because we're not a calculus-based class, but if we assume a constant acceleration, then calculus can give us a formula for velocity. And we can further use this formula in calculus to get an equation for position. And we can combine these two equations in various ways. So for instance, if we solve this for A and then substitute it in here, we get this equation down here from algebra, just doing that substitution. We can also get another equation by just doing some substitution with algebra here. If we solve here for time, and then take that and put it into time here in both these slots, we then can get this equation. So there is actually a third equation we can generate from algebra. If we solve this one for the initial velocity and plug it in here, we do get a third equation, and it's not used too much, but I will mention it anyways in this next slide. So algebra giving us the average values. And then calculus generates these two equations by assuming a constant acceleration. And then using algebra, combining these two together, we can substitute and get these other three. Now this last one on the bottom is the one that isn't used too much. A lot of times it's not even presented, but just to give you a complete picture here, these are all the equations you can generate. And just to add quickly here that if you're writing things down, don't write really this stuff down yet. I still got a little bit more to say. So when and how to use these. And I think the first part's pretty straightforward. If the problem simply asks you for an average velocity or average acceleration, then we'll use the algebra results. Those give us the average. Otherwise, you're going to use the other ones. So if it does not say anything about average, then using the instantaneous value equations. Now if you notice, there are a lot of variables here. And just to list them out for you. However, things do get simplified. So for instance, using the delta symbol, and if you don't know, the delta symbol is defined as final minus initial. That is its definition. So we can take final minus initial here, use a delta, final minus initial here, use a delta, and final minus initial here to use a delta to clean that up a little bit. But in reality, meaning the physics problems that get assigned, it's common to use A, but to break V into V final and V initial. So you won't see the delta symbol too much in homework. It is broken down into final and initial. In the homework, it's also very common to have the initial position to be 0. So when we do final minus initial, and if initial 0, then all we're left with is x final. And then what's just kind of a common tradition to do is just drop the f then. And so we get just x. And so just x is commonly used then for our position. And the same is true for time. So almost always, well, you should just assume time is 0 unless stated in the problem is how it'll work out. Time is always, for the most part, assumed to start at 0. And so final minus initial gives us, again, just final time. And then we tend to just not write f anymore. And so we get t. T means then our time. And this does bring our variables down. So now we're only dealing with 5. So just me state this again to be clear. The rigorous math way of writing these out would be to use the delta symbols. And again, common to not use a delta symbol for velocity. But using what tends to be true, where the initial time and initial position are 0, then the equations will look like this. And this is the final representation. If you want something to write down that'll be good for the homework problems going forward, this is the, I think, best way to present them. So using these kinematic equations. So again, these equations describe to us motion. And the motion here is assumed to always have a constant acceleration. And one thing I like to say a lot with these equations is I do think of it as kind of a puzzle game. That you have these pieces you need to put together and figure out how to put together, and then you have your final picture. And what that means is we're going to have these 5 variables. And these variables will be given to you in the problem, or they might be ones you have to figure out. And then when you have these variables, only certain equations will actually give you an answer. Because maybe an equation has too many things you don't know. So for instance, if you only know acceleration and only know position, well then you can't use this equation because it has too many things that are still unknown for you to get a number. That's what you want to look for. And here's just a quick example. Let's say a problem gives us time and gives us an acceleration and a velocity. But we don't know the final velocity. Maybe that's what the homework question is asking for. Given this information, what is the final velocity? And then we just use these numbers and determine which equations we can use. And a very rigorous way is you could just plug in all of the numbers into all the equations and just see which one gives you an answer. So if you wanted to be really thorough, and if you're not sure which one to use, you could do this. Plug all the numbers into all of these, and only certain ones will give you an answer. So for instance, if you look, we can get a final velocity. That one gives us an answer. We can also get a position. That one gives us an answer. But this one does not. This one does not. And neither does this one. Because there's too many things unknown in order to solve these equations. Of course, now that we've solved, say, for final velocity and gotten an 11, we can put that in here and then use that one. And that's what I mean by it being kind of a puzzle game. You got to look at your pieces. These are your pieces I would consider, and then you got to see how to place them. Placing them meaning how do they go into the equations, and then some of them will work and some of them won't because they won't give you an answer. So in summary, if the homework problem or question you have wants an average value, then we're going to go to the algebra expressions. Otherwise, we're going to go to the kinematic equations, which give us the exact values, the instantaneous values, the values exactly at some time of, say, 2 seconds. And to use the kinematic equations, we're always going to be looking for these 5 variables. And once we have those 5 variables, we'll see which kinematic equations can give us an answer. So check out the accompanying video where I work these problems out. I'm also going to say other information that'll be valuable for you. And I will see you Tuesday.